Hello, Miss. So this is Group 7 from RT1 S3G1. So Group 7 had there are three members in Group 7. Me, Chloe Ang Chi, Tan Zhen Chin, and Darren Lao Zirong. So we have been tasked to set up multiple local area networks for food processing manufacturing plant in Johor, Malaysia. To give an introduction on this assignment, we have four buildings in the manufacturing plant. Uh, okay, let's show them. Let's show the physical, the layout. Yeah. So we have four buildings: A, B, C, and D. And A has six departments, and each floor consists of two departments. Building B has two departments and one department each floor. Building C has three production lines, and building D has one production line and one department, which is manufacturing department. So it is important to note that production lines 1 to 4 are actually part of the manufacturing department, and each department has their own subnet except for the manufacturing department. We have decided to create a different subnet for each production line because in the case that uh, one of the switches uh, failed, we do not want it to affect other production lines. And so that is our decision. So based on this table, you can see that there is a number of host addresses that are required, but we also need to take into account the 20% growth of these departments. And so the total subnet capacity is the required host addresses plus the 20% growth. And so, for example, management department, it requires 30 host addresses, but once we add in the 20% growth, we have created a subnet that is 36 host addresses, the capacity of the subnet. And that and the same goes for every department and production line. So that is all for our introduction. Let me pass this to Tan Zhenqin.
Okay. Uh, Now I will talk about the addressing design, which in this case we used a VLSM IP addressing for this network. So why we chose VLSM? Because VLSM is much more flexible as we are not restricted to fixed length subnet masks that do not have any configurability. By using VLSM, we can give each subnet its own IP address instead of providing a fixed range. This way, there is less network congestion and there is also less wasted IP address. Because from the question, we know that if we include the 20% growth of usable IP addresses, for engineering R&D department, a total of 600 usable host ID is needed. So if we use class full IP addressing, subnetting, uh, that means each of the subnets will have at least 1,000 usable IP addresses, which in the end, we know that finance, it only needs 24 usable IP addresses after the 20%. So, which means it will cause a lot of wastage on the IP addresses. So now let's look at engineering R&D. Uh, the subnet address is 172.16.0.0, which is a class B private IP address. And the subnet mask is 255.255.252.0, and the prefix length is /22. The usable host address range is 172.16.0.1 to 172.16.3.254. And the last address, 255, is the broadcast address. Same goes to each and every department and subnet name. So now I'll pass it to Darren to talk about the network topology.
Okay, thank you, Zhen. Now we move on to the network topology that we have designed for Sri Muda Go Sendirian Berhad. As we saw earlier in the physical topology, there are four buildings: Building A, B, and C and D. So we have split them into different colors. Building A is shown with the yellow color. Building B is with green. Building D is with purple, and Building C is with blue. For the network topology, we have decided to give each individual department in each building their own switch. By doing so, this allows each department to have their own individual subnet. Why we did this is to reduce the traffic congestion between each individual subnet network. For example, if one building had only one switch, if one building had only one switch for the entire network, it would cause a lot of congestion between all the departments. Say for building A, there are 6 different departments. If every department is sending data through one switch to the router, the traffic congestion will be very major and will cause very slow speeds. So by having individual switches for each individual department, there will be less congestion, and it also allows one department from maybe building A to directly connect to another department in, for example, building D, manufacturing department, straight away without going through a main switch, as they have their own individual switch. So as we can see with the cabling network we have done, router A is connected to router C using a fiber optic cable. This is because the distance between the two buildings is 170 meters, and since it is over 100 meters, we are required to use a fiber optic cable, as a crossover cable cannot support the length, the distance of the building. The same is said for router B and router D, as a fiber optic cable is also used between them to connect each other. Router B is also connected to router C using a fiber optic cable, as their distance is over 100 meters. As mentioned previously, router B is connected to router D using a fiber optic cable because the distance between them is 160 meters. However, as we can see, fiber optic cable is not the only cable used, as shown through the connection from router A to B and router A to D. The connection between these routers are using crossover cable because the distance is below 100 meters, more accurately 80 meters. The same is said for router C to D, as a crossover cable is also used there. And for the configuration we have used, we are using Routing Information Protocol version 2, or RIPv2. Thank you. I will pass back to Zhen.
Okay, thank you, Darren. Now, let us take a look at the addressing table. Okay, so as we can see from the addressing table, we have listed out the device name, the interfaces, and IP address, subnet mask, and default gateways for each of the devices. So for router A, we used the Gigabyte Ethernet interface for more faster connections. So let's take a look at the router ports. So let's go into a router config, and let's take a look at the Gigabit Ethernet 0/0. As we can see, the IPv4 address is 172.16.13.37, which is the same as the table, and also the subnet mask 255.255.255.252, which is the same. So now let's check another port, Gigabit Ethernet 5/0. The IPv4 address here shown is 172.16.0.1, which is also the same here, and the subnet mask address is 255.255.252.0, which is also the same. Now, after checking the routers, let's check a random switch. So let's take finance for example. So let's go into the CLI console. So we've already set up the banners and the password. So the password is Cisco 2024. Let's enable password. The secret password is class 2024. Now let's show the running config of this switch. So we can see that we have the password encryption service enabled, and the hostname is finance according to the department name. And we have enabled secret 5, which means we've enabled the secret password. And this code is actually the password hashed out because of the password encryption. Now let's take a look at the interface of the switch. So the interface is VLAN 1 and the IP address is 172.16.13.2. Let's take a look here, which is the same. And then the subnet address 255.255.255.224, which is also the same. And the default gateway is 172.16.13.1, which is also the same here. Now, after that, let's do some connection pinging, just to make sure that our network is usable. So let's go to PC2, and then let's try to ping a random PC, PC38. So let's go to the command prompt, type in the command ping. Let's ping 172.16.9.254, which is the IP address of PC38. As you can see from the command prompt, our ping is successful and there's no packet loss. And I think that's all from us. So thank you.